Hello, my dear students. How are you? Hope you are keeping very well and hope you are listening my classes. Okay, but I need I need more engagements of my dear students. Okay, and today we came here to discuss some basic concepts. As one of my dear student has written in my comment box to please discuss something about alpha, beta carbon. What are the alpha carbon? What are the beta carbon? What are the alpha hydrogen? What are the beta hydrogen, etc. Okay. So, my dear students, now I try to make some basic concepts clear in front of you. Okay. Uh, and I realize in my long professional teaching career that the students often stuck in these basic concepts. Okay, they don't have crystal clear ideas about these basic concepts. So at first, going to the deep before going to the deep, we should take a short dip to these basic concepts. Okay, so let's start. And before starting, as I say in every classes, please subscribe my channel. And if you do have any queries, any doubts, write on the comment section so that I will get your questions. Okay, and please keep your notebook handy. Okay, so let's start. So first of all, if alpha, beta, gamma carbons in organic chemistry. So at first, alpha. What is the alpha carbon? What is the alpha carbon? So alpha carbon is the first 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 neighborhood carbon. First neighborhood carbon of a functional group. First neighborhood carbon of a functional group attached to the particular carbon atom. And people often mistake they often think that the carbon atom to which the functional group is attached is the alpha carbon. No. I must write down an example. Without any example, you can't get this. Okay, so CH3, CH2, C double bond O, OH, CH3. Okay, so in this compound is the keto group and the hydroxy group. This compound contains both the keto functional group and the hydroxy functional group and the hydroxy functional group. And if you consider the keto functional group, I repeat, if you consider the keto functional group, then this carbon is the keto carbon. Okay, mind it, this carbon is the keto carbon. This carbon atom is not alpha carbon. This is not alpha carbon. And my dear student often do this mistake. This carbon atom is not alpha carbon. Okay, what are the alpha carbon? The alpha carbon are the exactly first neighborhood of this carbon atom. So this carbon atom can be alpha carbon atom. This carbon also can be an alpha carbon atom. And beside the alpha carbon atom, this is the beta carbon atom. This is the beta carbon atom. So with respect to the keto group, okay, we regard this alpha group carbon atom with respect to the keto functional group, mind it. And the hydrogen atom, the hydrogens atom are beta hydrogens. So what are the beta hydrogens? Beta hydrogens are the hydrogens atom attached to the beta carbon. What are the alpha hydrogen? Alpha hydrogen is the hydrogens attached to the alpha carbon. So what are the alpha hydrogens? Hydrogen atoms attached to alpha carbon. And what are the beta hydrogen? Hydrogen atoms attached to beta carbon. Okay, so this is the basic thing. And if there are many other carbon atom other than beta like this, so this is called as gamma, etc., and then delta. Okay, so now in our example the organic compound contains both the keto functional group and the hydroxy functional group. In our example, I repeat, in our example both the carbon compound, the organic compound contains both the keto functional group as well as the hydroxy functional group. And till now we have discussed the alpha carbon atom, beta carbon atom, alpha hydrogen, beta hydrogen with respect to this keto carbon. Now we are moving forward to the hydroxy functional group. So with respect to the hydroxy functional group, where the functional group is attached, where the hydroxy functional group is attached, hydroxy functional group is attached with this carbon atom, this asterisk carbon atom, and this carbon atom is not alpha carbon atom, mind it. Again, this carbon atom is not alpha carbon atom. We are going to discuss alpha beta carbon atom with respect to the hydroxy functional group, and this carbon atom is not alpha carbon atom. So what are the alpha carbon atom? With respect to this moiety, this carbon atom is alpha, and this carbon atom is also alpha, this is beta, this is gamma. Okay, so alpha carbon atom, I repeat, alpha carbon atom is the first neighborhood carbon atom, this is the first neighbor carbon atom to this carbon atom with which the functional group is attached. Okay, so I think you make my topic clear, I can make you clear. Okay, so all these things are alpha and beta. Now people often struck to the two names, isopropyl, isopropyl and tertiary butyl. People often misunderstand, and people often bear misconception of these two terms, what is the isopropyl and what is the tertiary butyl. So isopropyl is nothing but the alkyl or moiety CH3 like this. So again I written here this curve. This alkyl group is called isopropyl alkyl group. So look, this carbon atom is attached with the two alkyl groups and one hydrogen group. So this carbon atom is a secondary. This carbon atom is secondary carbon atom. Secondary. Okay. Now what is the tertiary? Tertiary carbon atom. What is the tertiary? So why it is called propyl? Because this group contains three carbon, one, two, three. So this is called propyl. But this carbon atom is secondary type. Why I write secondary type? Because secondary can be secondary carbocation, secondary carbanion, secondary free radical, etc. So this is secondary type. I write secondary type, not mention any special kind of. Okay, special kind of means not I don't mention it secondary carbocation, secondary carbanion, secondary free radical. Okay, all these things we discuss later. So tertiary, what is the tertiary butyl? This is tertiary butyl. Okay, so look, this carbon atom or this carbon atom does not contain any hydrogen atom directly attached to this. Okay, so this is tertiary type. This is tertiary type. Okay, so this aesthetic carbon atom is the tertiary type. And why it is butyl? Because within the parenthesis, within the first bracket, there are total 4 carbon atom, 1 2 3 4. So it is butyl. So don't make any confusion. Okay, this is isopropyl, this is tertiary butyl. Isopropyl is secondary type and tertiary butyl is tertiary type. Secondary means this is 2 degree, this is 3 degree. Please write down these things. Now, type. Hybridization. So, first, carb cation. Carb cation. Carb cation means this. So, the carbon atom bears a positive charge, so it is a carbocation. And what is the hybridization? What is the hybridization of this carbon atom? What is the hybridization of this carbon atom bearing the positive charge? Central carbon atom. Central carbon atom means the carbon atom which bears the positive charge. This is the central carbon atom. So in case of carbocation, the hybridization will be sp2. sp2. Okay, so like this. This is the sp2 hybridization. This is the vacant anhybrid p orbital, and there are the two lobes of the vacant anhybrid p orbital. And what are the bond angle? Actually these three bonds, these three bonds are in same plane, are in a triangular plane. These three bonds are the triangular plane. Okay, so there are the bond angle. So what are the bond angle? The bond angles here, the bond angles are 120 degree. All the bond angles are 120 degree. Okay, so this is the special kind of carbocation. So the carbon atom bearing the positive charge is sp2 hybridized. So this is the carbocation. Okay, I am don't discussing the stability of the carbocation, and we can discuss the stability of the carbocation in the next lecture. I am just writing. I am just discussing the brief of some basic concepts. Okay, so now carbanion. Carbanion. What are the carbanion? Similarly, the carbanion is the carbon atom bearing the negative charge. And what is the hybridization of this carbon atom bearing the negative charge? Here the hybridization is little bit different than carb cation. Here it is sp3. So here it is sp3. So what happened? Here the sp3 actually, this is the type of the, and here two lone pair, here the one lone pair electron exists, and the bond angle, this is the tetrahedral, and this is the lone pair of electron. This is the lone pair of electron. Okay, now exception, and such questions regarding exception of any kind of theories are often asked in your competitive exams after plus 2. And if you are preparing for civil service and state civil service as well as central civil service, and here also such kind of exception are asked. Okay, these kind of exception questions are asked. So you have to make your concept clear. Otherwise you could not. Otherwise you can't solve this problem. You should first make your concept clear. Then only you can solve these questions. Okay. So exception. Now CH2 minus. So here it is the carbon atom. It is the carbon atom. So what will be the hybridization of this carbon atom? The hybridization of this carbon atom, you can guess sp3. Hybridization of this carbon atom, you can guess sp3. But no. Here the hybridization of this carbon atom is sp2. Why it is sp2? Because the carbon atom and the phenyl ring should be a similar plane like this. So the carbon atom and the phenyl ring should be on this similar plane, and the bond angle 120 degree, because here such kind of resonance delocalization of the lone pair of electron on the carbon atom taken place. And to to make this delocalization effective, the carbon atom comes in the same plane on the phenyl ring. That's why the hybridization of this carbon atom changes to sp2. This is not sp3, mind it. If the carb anion is attached to any groups with which it can make resonance structure, it can make electron, it's a lone pair of electron delocalized, then only the hybridization of the carbon atom changes from sp3 to sp2. Okay, that's clear. Now I am moving to the free radical. It is very easy. It is similar to the carb free radical. Free radical means the carbon atom contains a single electron, an unpaired electron. The carbon atom contains an unpaired electron. And what are the hybridization? What is the hybridization of this electron carbon atom? Hybridization is sp2. And what happened here? The the anhybrid p orbital contains an unpaired electron. Okay, my dear friend. So, in our next session, we will discuss the stability of the carbocation, carbonon, and free radical. Until then, I hope you all enjoyed this class and you all learned something out of this class. So, we will meet again in the next session. Till then, goodbye. And before leaving this class, I must request please subscribe my channel and please share, like, and comment on this channel and on every topic. And you can also write down in the comment section the topic you need to be discussed. Okay, you think the topic you think to be discussed, please write down on the comment section. Okay, so and if you need any PDF format of this class note, you can also write down on the comment section. Okay, so till then, goodbye, keep well.